Hello and welcome back to Neural Data Science. Today our lesson is on conditionals. We'll be asking the question, how can programs do different things for different data? Our learning objectives are to correctly write programs that use if and else statements and simple Boolean expressions. And secondly, to trace the execution of conditionals. Okay, so we can use if statements to control whether or not a block of code is executed. An if statement, which is more formally called a conditional statement, controls whether some block of code is executed or not. Structure of an if statement is similar to that of a for statement. So the first line opens with the word if and ends with a colon. You can see that here. And the body containing one or more statements is indented, usually by 4 spaces. So in the first example here, we have GDP. So this is gross domestic product of some country. Based on the Gapminder data set, and it's equal to 49,357. And then we can test if GDP is greater than 10,000, colon, enter. And again, Jupyter automatically indents our next line when it sees the colon. Print with a GDP of GDP. So we're going to plug in our variable value there. This is a wealthy country. Run that, and it says with a GDP, so it prints that statement out because that's true. 49,357 is greater than 10,000. If we had defined GDP as a value lower than 10,000, so GDP equals 5937, if GDP is greater than 10,000, and you know what, I'm just going to copy that line of code from above because it's the same command. Run that, and nothing happens because that statement is not true, and we didn't tell Python to do anything else if that statement wasn't true, so it just prints no output. Conditionals are often used inside loops. So for example, with one value of GDP, it's a bit trivial to run an if statement. But what if we have a number of values of GDP and we want to test each one against this conditional if GDP is greater or less than 10,000? Okay, so we'll say GDP equals square bracket, and let's put in these values. So 5,900, 36,100, 33,700, 7,400, and 10,700. Then I'll say for G in GDP. So here's my for statement. I'm defining a loop variable called G, and it's going to loop through the different values of in the list GDP. And for each one, we'll say if G, because remember G is our loop variable here, whatever the current value of GDP is, greater than 10,000, colon, print G. So we're going to print out the actual value, comma, is wealthy. Run that. And so now we get 3 outputs because 3 of these values are greater than 10,000, and no outputs for the other 2 because they were less than 10,000. So that's how we can test one truth statement, one conditional, and generate an output if that statement is true. We can also use the else statement to elaborate on that if statement and give Python an alternative to do if the first statement is not true. So again, our GDP values are the same. I'm not going to type these in because these were defined up above. But we'll say for G in GDP, if G is greater than 10,000, print, G, and then in quotes, is wealthy. And else, and you'll see that the else statement has to be indented the same as the if statement. So it doesn't get, when I hit enter at the end of this print line, you can see that Jupyter wants to keep me indented because it assumes that I'm still working on that loop. So you need to actually outdent to write the else statement. And else is also followed by a colon. And then print G, comma, is poor. Run that. And so now we get an output for every value in the list because each value is either greater than 10,000 or else Python runs this other line. The fanciest thing we can do here is use elif, which is short for else if, to specify additional tests. So we can go through a number of if statements, and then the else comes at the bottom, and that's basically the default response if none of the preceding statements are true. So again, the GDP values in the list are the same, and I'll say for G in GDP, if G is greater than 30,000, print G is very wealthy. And then outdent again, elif G is greater than 10,000, print, and whoops, I added a colon there, which I should not have added. So it's elif, and then the next conditional, and then the colon at the end. Now I need to make sure that indent is correct. Print G is wealthy. And then finally, my else statement, else colon, print G is poor. Run that, and now we've got three different outputs because 10,700 is between 10,000 and 30,000, so it gets the wealthy, whereas the other two become very wealthy. All right. One important thing to recognize about this is that the conditions are tested once in order, and so it's important what order you list your conditions in. For example, here's a case where if we put things in the wrong order, things don't work out right. So let's say that a student has a grade of 85. And we say if grade is greater than or equal to 70, colon, print grade is C. Okay, and then elif grade greater than or equal to 80, print grade is B. And then finally elif, and you can see you don't need an else statement. You can have one, but it's not required. So elif grade greater than or equal to 90, and print grade is A. Run that, and it tells me the grade is C. Now, looking at this, clearly that's wrong because the grade 85 is greater than 80, so it should be B. But the way Python works with conditionals is it tests the statements in order, and as soon as it finds one that's true, it stops executing the if statement and it goes on. So in this case, if grade is greater than 70, well, that's true for 85. So we print grade is C. We never even look at those other tests because we already found one that's true. So the appropriate way to do this is we'll take our grade there. So if grade is greater than 90, print grade is A. And then elif grade is greater than 80, print grade is B. And then finally, whoops, we don't need that. We'll just go down to the last line, else if grade is greater than 70, print grade is 3. So basically you think about the order in which these tests are going to be run. And if there's sort of a hierarchy like there is here, then you need to make sure that it will only pass sort of the test that's most important or most relevant. The same is true up above. So in this GDP example, we have if G is greater than 30,000 before if G is greater than 10,000. Because if we put the 10,000 first, then all the countries would be classed as wealthy, and the very wealthy ones would not get classed as very wealthy because it would never get to the 30,000 test if all the values are greater than 10,000. We often use conditionals in a loop to modify the values of variables. So here's an example where we define velocity is equal to 5.0, and then we say for I in range 5, so we're going to go from 0 up to 4 is our values of I. There we go. For I in range 5, print step I. So we're just going to sort of print out to the screen which iteration of the loop we're currently on. colon, and we're going to print velocity, so the current value of velocity. So the first time through the loop, this will be 5, because that's how we initialized the variable. Then we say if velocity is greater than 20, notice we're using floating point numbers here, print moving too fast. And then we adjust the value of velocity. So now velocity equals velocity minus 5.0. And then Elif velocity is less than 20.0, colon, print moving too slow. And then we're going to adjust velocity in the other direction. So we're going to add 10. Velocity equals velocity plus 10. And then finally we have an else statement which says print optimal speed. So before we run this code, you can sort of see a preview there, but let's think about this. So velocity is going to start at 5. And the first time through, if velocity is greater than 20, print moving too fast. Well, it's not. If velocity is less than 20, print moving too slow. And so in this case, 5 is less than 20, so it'll add 10. So then it'll be 15. One interesting thing here is that the optimal speed is exactly 20, right? So if velocity is greater than 20, we're going to adjust it down. If it's less than 20, we're going to adjust it up. But it has to be exactly 20 in order to get to this last test, or not test, but the last statement to print optimal speed. All right. And you can see the output. Step 0, step 1, at each case it's adjusting based on whether it's too fast or too slow. And then finally by step 3, it's achieved optimal speed, so we don't change anything. So step 4, it's still optimal speed. And this table just shows you kind of that if you were to think through stepping through the values without actually running the code, you would do something like that. So our next topic is compound relations using and or. So often you want to check if some combination of things is true. You can combine relations within a conditional, like an if statement, using the and or statements. So here's an example with GDP per capita and corresponding populations in millions for several countries in the year 2007. Let's define a power index for countries, whereby a country is considered very powerful if it's large and rich, where we define large as a population of more than 10 million, and GDP as greater than 10,000. We'll call it powerful if it's either large or rich, but not both, and not powerful if it's neither large nor rich. All right, so we've got the data pasted in here already, and I'm going to write for I in range len GDP. So that's already a nested statement that's going to find the length of GDP, so how many values are there in there? And it's going to set a range, so we're going to loop through all the values of GDP. We're not saying for I in GDP because we actually want to pull out the GDPs and the corresponding populations from the two lists, so the same position in both lists. So by defining I, first time through I equals 0, so we'll pull out GDP I is 5,900 and pop I is 3.6, etc., etc. So I say if pop square bracket I, because we're using indexing, right? So the value of population at index I is greater than 10.0, and GDP square bracket I is greater than 10,000. Print country is very powerful. And then Elif pop I is greater than 10.0, so 10 million, or GDP I is greater than 10,000. Print country is powerful. And then finally else, because this is kind of the default, if none of the above is true, print country is not powerful. Run that, And so for each one, it's saying country is not powerful, country is powerful, country is very powerful because their GDP is over 10,000 and the population's over 10, etc., etc. So in the first line, we used the and to say it had to be, both of those had to be true. The second line, given that if we get to the second statement, the Elif, that means the first one wasn't true. So then we test if either one of those on their own is true. And then finally, we print country is not powerful if none of the above statements are true. Again, the order of these statements is important. So if we'd put the or statement above the and statement, it wouldn't have worked properly because the ones that qualify as very powerful, because both of those are true, would also have the or statement be true. Now, sometimes you want to combine multiple and or statements. For example, if we continue the example above, we could define a further nuance whereby a country could be considered very powerful if it has a population of greater than 10 million and a GDP of greater than 10,000, or we could still call it very powerful if it has a GDP of greater than 30,000, regardless of its population size. We could rewrite the first conditional statement from the above example as you see here. If pop I greater than 10 and GDP I greater than 10,000, or GDP I greater than 30,000, print country is very powerful. However, this is kind of ambiguous because we don't know how the and statements and or statements sort of cluster together. So the above statement could potentially be interpreted as if the population is greater than 10 million and the GDP is either greater than 10,000 or greater than 30,000. So that's equivalent to writing it this way. So we put parentheses around this part of the code. So it's testing GDP greater than 10,000 or GDP greater than 30,000. Of course, that doesn't really make sense because if it's greater than 10,000, if it's greater than 30,000, it's also greater than 10,000. So that's obviously not what we intended. But Python doesn't have that level of sort of human intuition. So alternatively, and what we actually mean is if population is greater than 10,000 and GDP is greater than 10,000, if population is greater than 10 million, GDP is greater than 10,000, or simply if GDP is greater than 30,000. So we want to use these parentheses to tell Python specifically which statements we want to evaluate together and which we want to evaluate separately. So the second one in this case is, of course, what we want to use. Now, Python has a precedence order, what in math we call order of operations, and it evaluates and statements before or statements. So even without the parentheses, this code would actually work right, but we don't have to remember that if we use the parentheses, and our code is more transparent and understandable by other people if we actually use those parentheses to make our code more explicit, rather than just relying on people to know what the rules are. All right, so this brings us to the end of the lesson. It's a short lesson, but an important one, and we've learned quite a lot, actually. So let's try some exercises now. As usual, pause the video, work through these exercises on your own, and then unpause the video and we'll work through them together. Okay, so let's work through these exercises. Our first job is to actually run the different variants of the code that we have above, combining and or in different ways, and see what happens. So the first step is I'm going to go back and I'm going to take our GDP and pop values and the first line there of for I in range, paste that in here. So for I in range, and the first variant is this one without any parentheses. I'm going to copy that, reformat the cell, paste that in, make sure my indent is correct inside my if statement. So this one, if pop is greater than 10,000 and GDP is greater than 10,000, or GDP is greater than 30,000, print country is very powerful. I'm not even going to run the other lines because we just care about this one. By other lines, I mean, if it's not very powerful, what is it? Okay, so 4 of the countries are rated as very powerful. Now, if I take this code, paste it below, and then the second example, just for the sake of argument, again, this doesn't make a lot of sense to test if GDP is greater than 10,000 or greater than 30,000, or run it, only 2 countries are then considered very powerful. And then again, paste that in, and this time put the parentheses around these 2, so it'll test whether population is greater than 10 million and GDP is greater than 10,000, or simply GDP is greater than 30,000. Run that, and now country is very powerful. 4 countries are considered very powerful, which is the same output as if we ran it without the parentheses. So again, Python's order of operations, it tests and statements before or statements, but it's much clearer to you later on, to other people reading the code, if you use these parentheses to explicitly tell Python and anybody who's reading the code which tests are sort of meant to be grouped together and performed first relative to other tests. Next task is this tracing execution one, where without executing the code, I want you to predict what the program prints. Then you can run it and see if you're correct. So our pressure starts out as 71.9. We run the code. If pressure is greater than 50, pressure equals 25. So yes, pressure is greater than 50, so we're going to change it to be 25. Now, Elif, pressure is less than or equal to 50, pressure equals 0. So we might think, oh, we've updated pressure, so now it's going to be less than 50, so it's going to change to 0. But remember, that's not the way Python works. When it's running an if statement, it goes through, and as soon as it finds something that's true, it stops running that section of code. So it doesn't do any of the other tests. So pressure starts out at 71.9. That's greater than 50. We adjust pressure to 25. Then we skip the elif statement altogether, and then we print pressure. So indeed, I'll copy this code, run it, and pressure is 25. There we go. Next one is trimming values. So we want to fill in the blanks so that this program creates a new list containing zeros where the original list values were negative, and ones where the original list's values were positive. All right, so let's look through this code. So we have an original list. It's called original. It's a list, and some values are negative, some values are positive, some values are 0. And result is, okay, and I'm going to grab this code, copy it, paste it so that I can edit it. And we want to create a new list. Result is what we're going to call it. And so we want to start with result being an empty list so that we can add things to it. And then we say for value in original, so value is our loop variable. So first time through value is going to be negative 1.5. So if what? Well, we want to test value, and we want to say if value, we want to say if the original list values are negative, we want to append a 0. So here, whatever the truth statement is here, we're going to append 0, so we need to test if it's negative. So if value is less than 0, 0.0, because we're working with floating point numbers, result.append is 0. And then we want ones where the original list's values were positive. And we'll treat 0 as a positive number in this case. So else result.append, so same thing, except now result.append is 1, because we want to add ones. Okay, and sure enough, the negative value gets changed to 0, the positive values and 0 all get changed to ones, negative 1.3 becomes 0, and positive 0.4 becomes 1. Our next exercise is on initializing, and this is about initializing values of variables and then updating them. So we want to modify the program that you see here so it finds the largest and smallest values in the list, regardless of what values are actually in there or how many there are. So I've copied the code, I'm going to paste it in down below and then start modifying it. So the first thing I'm going to point out is that we've initialized our accumulator variables to be none. None is a special value, or actually a type in Python, which basically means no value. So it's kind of a placeholder. We don't want to initialize smallest and largest as 0 because we don't actually know if 0 is in the list and if it's actually the smallest value or not. So we don't want to create errors right off the bat. So we're just defining those both as none. And then the first thing we do inside our for loop, so we're going to loop through each value in this set of values, And first we want to test, is this the first time through the loop? So are those accumulator variables that we're using to track the smallest and largest numbers? If it's the first time through the list, they'll both be none. So we want to assign to them the first value in the list, because at that point we've only seen one value. So by definition, it's both the smallest value that we've seen and the largest value that we've seen. So we're going to write if smallest equals none. And the equals symbol here, two equals, is how we test equivalence. We can't use a single equal sign because that means assignment in Python. So in Python, if you want to test if two things are equivalent, then you use equals. So if smallest equals none, let's put spaces in there for good syntax, and largest equals none, then we're going to assign v to both smallest and largest, because again, it's the only value we've seen. It's both the smallest and largest so far. Okay. If that's not true, then we must not be at the first position in the list. So now we can test the current value of v against the already determined values of smallest and largest to see if v is now smaller than or larger than the existing values of smallest and largest. So since this is the only other option, this is going to be else. And we'll say smallest equals the min of what and v. So the min of smallest, because we want to compare which is smaller, smallest, or the new value v. And similarly here, largest is the max of largest, current value of largest, and v. So if the current value of v is larger than largest, largest will be updated with the current value of v. Otherwise, it stays as what it was before. And then finally, it's going to print out the results. All right. And it prints out minus 54 is the smallest value and 100 is the largest value. Okay, so there's follow-up questions here. What would be a simpler way of finding the smallest and largest values in that list values? Well, we could just run min on the entire list, and we could just run max on the entire list, and that would tell us. So what are the advantages and disadvantages of using the method above to find the range of the data? Well, there aren't a lot of advantages, really. It's a lot more inefficient in terms of the number of lines of code. And our next and last exercise is identifying variable name errors. So look at the code below and try to identify what the errors are without running it. Then run it and read the error message. Okay, so hopefully you've looked through the code and run it, and it's going to throw a name error. So let's see. Let's copy this code, run it. Name error, number is not defined. Okay, and number in quotes, meaning that the variable that we've called number, it's not defined. So why did this happen? Well, look at the first line. For number in range 10, number with a lowercase. So that's appropriate naming convention for Python variables. But then when we ran the if statement, if number modulo 3, number is capitalized. So the name error is because we used the wrong case. Okay, so we fix that, we run it. Oh, there's another error. Okay, so what's this one? So if number modulo 3 equals 0, so if it's a whole number, basically, then message equals message plus a. But it says message is not defined, and sure enough, the first time we run this loop, it's trying to assign some new value to message based on an old value of message plus either A or B. It's not going to work because we never defined a message in the first place. So for number in range 10, message equals message. So message is probably going to be a numeric variable, right? Because we're adding to it a value of A. So let's say message equals, we could make it 0, or as I said before, maybe none is an appropriate value since we don't know ahead of time. Okay, next. Now, it turns out this code is riddled with errors. So A is not defined, right? So we're trying to add message and A, but neither of those variables was actually defined. And the code here and the instructions don't really tell us what the heck A is supposed to be. So we don't really know, except that it's wrong. But maybe Use A if the number is a multiple of 3, otherwise use B. Okay. Well, maybe A is supposed to be a character. B is already a character, so that sort of cues me that maybe A was supposed to be a character as well. That makes sense. There's no mention of a variable called A, so probably the error there is that we wanted to make message actually a string, not a number. And so I'll run that, and now we have unsupported operand types for none type and string, right? So I define message as none, but that's not actually appropriate because none is actually a numerical type that represents no value. So instead, I'm going to make that an empty string, since I'm going to be appending strings or adding strings. Run that. And finally, my code works. Hooray. So I got so it's just a sequence of A's and B's. And really, the exercise was not so much about what the code spit out at the end as just detecting these errors and sort of talking through the logic of trying to debug this code. Hopefully, when you're writing code, certainly you'll make these kinds of errors, and that's pretty normal. Hopefully, you'll have a better idea up front of what the code is supposed to do, so there will be a little less sort of logical thinking there. But nevertheless, this is kind of the process that you have to go through when you're debugging code. All right, so that brings us to the end of the lesson. To summarize the key points, we use if statements to control whether or not a block of code is executed. Conditionals are often used inside loops, so we might loop through a collection like a list of values and apply a conditional test to each value to determine if it's greater than less than 0, greater than less than 10,000, or whatever. We can use the else statement to execute a block of code when an if condition is not true, and we can use elif if we want to specify additional tests. So an if statement will go through in sequence, first test the if condition. If that's not true, it goes to the first elif statement. If that's not true, you could have an additional elif statement and would evaluate them in sequence. As soon as it finds one that's true, it stops, it runs whatever code is under that block, and then it stops executing the rest of the if statement and goes on to whatever's below it in your code. So the conditions are tested once in order. That's the end of our lesson for today. Thanks for watching. Take care, and we'll see you next time.